Welcome to Millionlights. My name is Pratik Shah. I am an assistant professor in DY Patil School of Engineering. In the previous module, we had discussed about robotics. We had seen how we used Arduino to control robot. Now, at the end of that module, we had also seen 7-segment display. We had seen the introduction to it. In this module, we'll explore the concept further. We'll be using 7-segment display. We'll use Arduino to control it, and we'll be using Arduino to display various digits on it. At the end of this module, we'll be using PC, and from that we'll be doing serial communication. So we'll be sending digits from PC to the Arduino, and then Arduino will control 7-segment display and it will display those digits onto the 7-segment. In the previous module, we had discussed about 7-segment displays. Now we'll go with it further. This is a 7-segment display. Now it is used to display digits. We can display 0 to 9 on it. For that purpose, it has got 7 LEDs. Those LEDs are placed at particular slots. So when these LEDs are on, they give out different lighting patterns. Now we'll see in this presentation, here we see 0, 1, 2, 3. So in this way, various digits are displayed based on the patterns in which LEDs are glowed. Now for making this happen, we have got 7 LEDs and we have to switch them on. For that, they are placed at particular slots, and to switch them on, we have got these pins. So totally we have got 10 pins. Out of them, 7 pins are for LEDs and 3 pins are left out. Out of them, 1 pin is for this dot. So sometimes we want to display 1.3, 1.4, something like that. So when we want to display the decimal or dot, for that purpose we have this 8th LED, and the 2 pins that are remaining, those are used for common ground or common VCC. Now what is this concept? If you see in this presentation, these LEDs, now we have got 7 LEDs or say 8 LEDs, therefore we'll have 16 or 14 terminals, but in them we do not place each and every terminal outside. We connect one common anode or common cathode of these terminals. Means we either club all the anodes together or cathodes together. So this will do what? It will reduce half the pins in a single go. So here we have got 8 LEDs, 7 for displaying digits and 1 is for displaying the dot. So what we are doing is, in that 8 LEDs anode is clubbed together and it is made as common anode, and then we have got just 8 LEDs cathode. So based on the signal that we provide to the cathode, the LED glows or it doesn't glow. So this is a common anode configuration. Now if you see here, the name starts with CA, therefore this is a common anode 7-segment display. Means what? The LEDs that are used, all the LEDs, the anodes of them are clubbed together. So it is our responsibility to provide it with VCC, that is 5 volts. So we have got 10 pins in total. Out of them, 8 are for LEDs, 7 for 7-segment, and 8th one is for the decimal or the dot. So we have got that. Then 2 pins are there for common anode. So these common anodes are the pins that are at the center, that is the third one in the top, third one in the bottom. So they have to be clubbed together and they have to be given to 5 volts. So that sums up the pins part. So we have seen the pins. Now we have to see how exactly and which pin can control which LED. So if you see this presentation, here you can see that A, B, C, D, E, F and G, this is written on this 7-segment, and corresponding to this we have pins. So if you want the uppermost LED to be on, then you have to connect the pin number 4 on the top of the 7-segment to ground. Now since we are keeping all the anodes common and they are given 5 volts, so for LED to glow, we have to connect the cathode to the ground. So if we keep it floating, it will not glow. If you give it 5 volts, it won't glow. So these cathodes are to be clubbed together and they have to be connected to ground. So for connecting to ground, we are using Arduino. So Arduino is used to connect to all these 8 pins, and depending upon our logic, we will use and will make those pins from Arduino to go low. If the pin is high, it will not glow because anode is positive, cathode is negative, the current cannot flow. Current only flows from higher potential to lower potential. So at the anode we are giving 5 volts, at the cathode from Arduino we have to connect it to low. So if I want to make the uppermost segment of LED glow, then I have to connect pin number 4 from the top to any pin on Arduino, and then I have to write digital write that pin and low, then only that pin will glow. So if you take a look in this slide, we have got A, B, C, D. In this way we have marked these things. So what is A? A is the uppermost part. So if I want to glow this, then I have to give pin number 4 on my 7 segment as low. If I want this pin, that is the rightmost pin at the topmost corner, then I have to give pin number 5 as high. Then if I want to glow this one, then I have to connect pin number 4th at the bottom. I have to connect it to low. Then similarly you can see we have D, E, F and G. Now these are given with this appropriate positions. Now this dot, if I want to switch it on, then the 5th pin on the bottom should be connected to low. So this is how we can do the connections. Now we will see how we are going to connect this to Arduino. Okay. So this is the circuit diagram that I have prepared. Here we have got a 7 segment display, and that is connected to Arduino. So first thing that we'll see is the center pin, that is the third number pin at the top and the bottom. I have clubbed them together, I have shorted them, and I have connected that to 5 volts. So common anode is taken care of. So this part is done. Now I have to connect all the other pins individually. So for the purpose of ease of programming, what I'll do is I'll consider A pin as first pin. So I have to connect it to pin number 1 of Arduino. B pin can be used for connecting at pin number 2. C pin can be used for connecting at pin number 3. Similarly, D for 4, E is 5, F is 6, and then G is 7. So that will ease the things, but I cannot connect pin number 1 from Arduino to pin number A, because 0 and 1, these are the two pins that are used for transmission and reception of data in serial communication. Now serial communication is done while uploading the code from PC onto Arduino. So normally it is a good practice to keep 0 and 1 as it is. We do not touch them. Okay. So instead of connecting 1, what I'll do is I'll take pin number 10. So pin number 10 is connected to 4th pin on the 7 segment, that is it is connected onto A. Okay. So second pin is connected to second pin on Arduino, that is B pin. Then C pin is connected to pin number 3. Now C pin is here, that is the 4th pin at the bottom. Then the 4th pin is connected to D, and D is the second pin at the bottom. Then 5th pin is connected to first pin of the bottom. So 5th pin is corresponding to E. Then we have got F and G. Now 6th pin is connected here, and then 7th pin goes here. So this is how the connections can be made. Now one thing that is left is this dot. So dot is connected to pin number 13. So here A is connected to 10, B is connected to 2, C is connected to 3, D is connected to 4, E is connected to 5, F is connected to 6, and G is connected to 7, and DP, that is dot, is connected to 13. So in common they are connected to 5 volts. So connection is quite simple. Now what we'll do is we'll use breadboard 7 segment display, we'll connect this stuff, then we'll see the programming part, and we'll see the expected output. Now we'll see the circuit diagram, and we'll see how the connections are made. First of all, we have to connect these third and the third pin from the top and the bottom to the VCC. Then 4th pin on our 7 segment, that is this pin, is to be connected to pin number 10, because this is A and this is the first pin where we want to connect. Now this second pin, that is B pin, is connected to 2 on Arduino. Then we come here, this one, the 5th pin at the bottom is DP, so we can connect it to our pin number 13. So we are connecting it to pin number 13. Now yes, here we are connecting to pin number 13. Then we are left with C, D, E, F and G. The C is this pin, the 4th pin at the bottom. This is to be connected to pin number 3. Then we have got common ground here, so this part is left. Then this is D, this is to be connected to pin number 4, and this is E, this is connected to pin number 5. F is this second pin at the top, therefore this is connected to 6, and this first pin at the top is G, so this is connected to pin number 7. So here we have connected 7 pins, and we have connected DP, and we have connected this common anode, that is plus VCC. So these are the 10 connections that we have to make, and these connections are made according to this structure. Now here A is 1, B is 2, C is 3, D is 4, E is 5, F is 6, and G is 7. So based on this, it is easy to program. So here we cannot connect 1, therefore we are connecting 10 to the A pin, and DP is connected to pin number 30. So suppose I want to display 1, then what I have to do, I have to switch on B and C. That means I want to glow B and C LED. That means I have to ground, or I have to make digital write low to pin number 2 and pin number 3, and rest all pins will be high. So that is the part that we have to see in programming. Now let's build the circuit on the breadboard, and then we'll talk about programming. For building this circuit, we require breadboard, Arduino, 7-segment display, USB cable, and connecting jumper wires. Now first we'll start with mounting the 7-segment display on the breadboard. Okay, so now it takes some time to fix the slots. Okay, so I mounted this here. This is the top part and this is the bottom part. Now we'll start making the connections with the help of this jumper wires. First we'll connect the ground, the common pins, that is this pin. I'll connect it down so that it's easy for connections, so that it will have some room to connect the jumper wires. Okay, so the common pins are shorted together, and I'm connecting it to VCC. Okay, so this is done. Now one by one we'll connect all these pins. So this pin, that is A pin, this is connected to pin number 10. Okay, so this is connected to pin number 10. Now B pin, that is the 5th pin on the top, this is connected to pin number 2. This is connected to pin number 2 on Arduino. Okay. Now we have to connect pin number C. Now this is our DP pin, that is the pin for dot. This will be connected to pin number 13, 12 and 13. This is used for displaying the decimals. Now the 4th pin on the bottom, this is pin number C, and that is to be connected to pin number 3 on my Arduino. Okay. Then pin number D is the 2nd pin at the bottom. This is to be connected to pin number 4. Then first pin, bottom pin, that is to be connected to pin number 5. Now we have just 2 pins to connect, that is F and G. The first pin is G pin. So instead of connecting it, first we'll connect F pin, that is 2nd pin. So we'll connect that pin to pin number 6, and then the first pin on the top to pin number 7. So this completes our connection. 1, 2, 3, 4, 8 pins are connected to our digital pins, and then we are connecting VCC to these pins. So this completes the connection. Now we will connect it to PC with the help of USB cable. Okay, so this with this we complete the connections. Now we'll see the programming, we'll see the expected output, and according to that we'll see what the program should be. Now we'll see the programming part. In this, the expected output is our 7 segment should display 1. Now for 7 segment display, to give output as 1, what we have to do is we have to switch the pin number B and pin number C to low. If these two pins are made low, then 2 LEDs will be on and it will give us output as 1. Now for that, we are connecting it to Arduino, and pin number B and pin number C is connected to pin number 2 and 3 on the digital pins of the Arduino. So we have to make digital write 2 as low and digital write 3 as low. So if we do that, we'll be able to make the 7 segment to display 1. Now first of all, we'll take a look at the programming part. This is a very simple code because we just want to display a digit 1. Now we are not displaying every digit from 0 to 9, nor are we going for serial communication. So this code is very small and simple. We first explore it and then we'll go for the serial communication code. Okay. So here two things are there, setup and loop. In setup, what we are doing is we are initializing the pins as input or output. Here there is no pin that is input because we are just controlling the 7 segment. So each and every pin from Arduino is an output. Pin number 2, 3, 4, 5, 6, 7 and 10, 13. These pins are output. 2 to 7 is nothing but B to F, B to G, and 10 and 11 is 1 and DP. So these are low output. Then we have got void loop in which we have to make the logic. Our logic is that we want to display 1, that means B and C should be low. So for that, they are connected to pin number 2 and 3. Pin number 2 and 3 should be low. Hence these two LEDs will be in forward bias and they will glow, they will emit light, making a pattern of 1. Rest all should be high. So that is the code that we have written. 13 is high, that means the dot is off. 2 and 3, these are on. Then 4, 5, 6, 7, 8, these all are high. So this is a quite simple code which will make our 7 segment display to make an output as 1. So now what we can do is we can upload the code and we'll see the output. Now let's upload the code onto Arduino and we'll see the output. I'll press the upload button. The code is getting uploaded on the Arduino board. Okay, so the code is uploaded. Now we can see the output. The output, expected output was it should display 1 and it is doing it. So according to this, you can write any code. You can display 2, 3, 4, 5, 6, anything. Just you have to take care about the LEDs that should be on. So if you want to display 2, you have to see which LED should be on. So depending upon that, you can write the program and you can make those pins as low. Now we'll do something new. Now we'll develop the code. Instead of just displaying the code, we'll develop the code. What is the expected output? Expected output is that from the PC, I'll press any button from 0 to 9. And depending upon that key pressed, the output should be displayed on 7 segment. So we require serial communication from PC to Arduino, and Arduino should control this 7 segment display. So we'll see what the code should be. Okay. So we'll modify the same code which was used in the previous experiment. This is the code that was used. Now we'll have few modification depending upon the output. First thing that I should write here is serial.begin in void setup because we want serial communication. Serial.begin. And I have to mention the baud rate. Baud rate is 9600. Okay. So first part was to tell that I am going to use serial communication. Now second part comes inside void loop. Here what we are going to do is, this is Arduino side. So we are continuously checking that whether some data is transmitted from PC to Arduino. If it is transmitted, then we have to take the decision. So to check whether the data is transmitted, we have to use serial.available function, and that is used inside if. Therefore I have got if, and in that if condition I'll write serial dot serial dot available greater than 0. So if the data that is transmitted is greater than 0, that means some data is transmitted from PC, then only I have to execute this code. So for that purpose I have to write all the code inside if. Okay, all this coding stuff will go inside if. Okay. Now here I have to make conditions. Here first of all I have to store the value, I have to read the value that is being transmitted from PC, and that is to be stored in some variable. Hence I'll declare a character variable, and the name of character variable can be anything. I'm naming it as A. A is equals to serial dot read. Okay, so here what I'm doing is I am reading the character, and based on the value, the value stored in the variable A, and the based upon the value of A, I'm taking decisions. So first, if the value is equals to 1, now if the value is equals to 1, then I want to display 1. I'll take these things down. That's it. We already had the code for displaying 1 because it was written previously. So same thing I have repeated. Now we have to build a logic for 2, 3, 4, 5, 6 and all. But this is the main building block. We go inside loop. There we check whether the data is available or some data is transmitted from PC to Arduino board. If yes, then we read that data and store the data into a variable called as A. And then we check the value of A, and depending upon that we take decisions. If A is equals to 1, then display 1. If it is 2, then display 2, 3, then 3. So for 1 to 0, everything will have a different code. So we have to write that code, and that code is to be placed inside if else if blocks. So that is what we are going to do. This is the basic structure that we have. Now I have used if condition, and I am checking, okay, there is one mistake that we have done. Instead of just single equals to, we have to use double equals to. If we use just single equal to, that is nothing but assignment operator, and if we use double equal to, that is condition checking. So we have to check whether A is equals to 1. If A is equals to 1, then connect pin number 2 and 3 to ground. Now in the same way I have to write the code for A is equals to 2, 3, 4, 5 and so on. Okay. So this was for if A is equals to 1. Now I want to check the condition if A is equals to 2. Okay. Now in that I'll write the code. You can see that I'm using else if. Now why I'm using else if? Because if one condition is not satisfied, then I'm checking the another one, then the third one, then the fourth one, because in them only one will be executed. If I use 10 if conditions, then what is happening? Each and every condition is being checked. When I am using else if, one by one we are checking condition. If any condition is true, all the else if statements are skipped. Okay. Now we want for A is equals to 2. Now for A is equals to 2, what I'll do is I'll have to make the logic, but this same code can be copied and pasted. So the code that was used for A1, that is used, that is pasted here, and now depending upon the LEDs to be on, I have to make the logic and I have to make them low or high. Okay, let's start with pin number 13. Pin number 13 is used for dot. I don't want it, therefore it is low. Now pin number 2. Pin number 2. Okay, before that let's talk about pin number 1. Pin number 1 is the topmost pin. Now if you take a look at this presentation, you can see that pin number A, that is the first pin and that is the topmost pin, and that we want high for 2. Hence pin number 10 is to be written as low. Okay, so 10 is done. Now pin number 2. Pin number 2 is B, that also we want, therefore it is made as low. Then pin number 3 is C. We don't want that to be high. That means we don't want it to be glowing for 2, therefore it has to be made as high. Okay, then we are talking about 4. 4 is D pin, and D pin we want it on, therefore it is to be made as low. Then 5 is E pin and we want it on, therefore it has to be made as low. Okay, then we are talking about 6, that is to be made as off, therefore it is to be high, and then 7th, that is on, therefore it is to be low. Okay, so this completes the part of 2. That means if I press 2, it will check the value of A is 2 and it will make this arrangements. So for displaying 2, I want 1, 2, 3, 4, 5. 5 LEDs should be on. Therefore, I should have 5 digital pins that are low. So that is done 1, 2, 3, 4, 5. So this is code is okay. Now the same thing is to be repeated with 3, 4, 5, 6, 7, 8. So depending upon the requirement and depending upon the expected output, we can make it. Okay. So I'll just make this thing for 3 and 4, and then I'll make it, I'll leave it, and then you can extend this concept further. Okay. So one more thing that we need to take care is the brackets. Now this one is for loop, this one is for the if, that is used for serial communication, and this is for the local else ifs. So here is the place where I paste my code, and here I take decisions. So else if A is equals to 3, now if A is equals to 3, then what I want to do is I want to display 3. Now when I want to display 3, then which LED should be on? The first LED, that is A LED, should be on, so that should be on, that means 10 should be low, that is done. Now 13 is for DP, I don't want it to be glowing, therefore it is high, that is also okay. Now for 3, B should be low, so it is low, correct. Then C, that is the third pin, and that is also to be on, so it should be low. So is it low? It is not low, so I have to make it low. Okay, so it is fine. Now D, D is the bottommost part and that should be also on, so it is low, correct. Then F, E, okay, E is one part that is we don't require it to be on, therefore we can make it as high, so it is to be made as high because we don't want it to be glowing. Then we have 6 and that is F, we also don't want it to be glowing, so it is to be made high, it is already high, fine. Then G, G should be low because we want it to glow, that is done, that's it. So this is also complete. Now what I want to do is 1, 2, 3, 4, 5. 5 LEDs should be glowing, therefore I should have 5 lows, 1, 2, 3, 4, 5, and this is perfect. So in this way what we can do is we can write the code for 4, 5, 6, 7, 8, 9, 0, and finally if you want all the LEDs to be off, then what we'll do is we'll write else. Now if any one of these condition is not satisfied, then the else will be executed. In that else, what I'll write is I'll make all the LEDs low. So that is the default condition, that if no key is pressed or if some key is pressed which is not according to our logic, then all the 7 segment LED should go low. Fine. So I have to write high in all the places. Okay. Now you can notice that whenever I write the code, uh, the characters or these words change from black to blue or red because they are defined in the libraries. So if you don't find them turning in different colors, then there is some issue. Okay, so I have written the code that will display 1, 2 or 3 on my 7 segment, and if some other key is pressed, then all the keys will be low. We'll compile the code and check whether it's working properly or if there are some mistakes. So it is being compiled. Okay, so that means there is no error and there is, this code is absolutely fine. So we have written the code in which we'll be pressing alphabets or keys from our keyboard, and that will be displayed on 7 segment. We have written the code just for 3 digits, we have compiled it. Now what we'll do is we'll upload the code and we'll see whether it's working properly. Now let's upload the code and we'll see the output. Okay, the code is getting uploaded. Okay, the code is uploaded. Now here you can see that it is displaying a garbage value. Okay, so now we'll use our serial communication. I'll transfer the data from my PC. I'm using serial monitor. Now here I'll type 1 from the keyboard, and that data will be transferred from PC to Arduino. Arduino will detect that value, and depending upon that it will display on the 7 segment. Okay, so I'm transferring 1. Now that is getting to Arduino and it is displaying 1. In the same way, we can code the data for 4, 5, 6. We have just coded it for 3 things. You can code it for all the other things, and you can make the program and you can get the expected output. Hope you like the video. If you have any queries, you can find us on Facebook by the name Millionlights, or even on Twitter. You can visit our website www.millionlights.org for more such interesting courses. Thank you.